Hello, my name is Moises Pacheco, and in this video I'm gonna be showing you my submit for the Advanced Data Science Capstone from the specialization program of Advanced Data Science with IBM. First of all, I would like to say that this project is just for handwritten number recognition. In the future, I would like to do a handwritten symbol recognition for mathematical operations. And like that, with just one photo, we can do a mathematical operation since all the symbols in the equation are identified. We're going to use the MNIST database from Keras, which contains digits from 0 to 9. We're gonna have to use Keras and TensorFlow as well. So here we install it. There we can import the MNIST database. We're going to follow a step-by-step by the capstone. So first we're going to do initial data exploration. The data is contained on a tensor. The first dimension is 2, the second is 4. The other dimensions are 60,000 by 28 by 28. That's the information given from the database. I have to say that the data quality is pretty good. The images are centered and also normalized, so there is a really good quality and there is now not too much processing to do. So data can be loaded really fast. We have X train, Y train, we have also X test, Y test. So in that array we have the data of the images and also the labeled data. So we have for each sample, if it corresponds to a number, it is already labeled. We now can pick an example from all the data and we can see that they correspond to a number, as you can see here. And we also can see the label, in this case is 8. In a separate document, I have all the architectural decisions made described, so you can check that out. The fourth step is ITL, Strat Transform Load. We are working on a non-deep learning and on a deep learning model, so that's why we have two. In this case, it was really easy. We load the data and we reshape it. The data contain images of 28 by 28 pixels, so all we did was reshape it to 6000 and 784. We also make sure of the data we're working with, so we have the type of float 32. The second step is for ITL process for the deep learning model data. In this case, we're working with a convolutional 2D network, so the input shape of the data is different. We also make sure that we're working with float 32, so we assign that type of data. As well, we have to normalize, so we divide it by 255. That made the intensity of the pixel from 0 to 1. This normalization is done to the non-deep learning model and the deep learning model. The next step is the feature engineering. For both cases, we're just using an one hot encoding, and which is really suitable for multiple class classification. The next step, the step 6, is the model definition. For the non-deep learning, we're just using a softmax regression, which is really easy to implement with Keras. It's a sequential model since we're just giving an input vector and receiving a vector as output. And these lines of code, we're just creating a folder in which we're gonna save all model later. So now we are going to do a loop in which we implement some optimizers and some activation layers, activation functions for some layers. The output layer is a have a activation function softmax. Then to compile, we use the loss of categorical cross entropy since it's suitable for image. And the model performance indicator is accuracy since we have already a known ground truth. So we are just going to evaluate the average of the correct predictions over the numbers of examples in the test. Then we feed the model with the trained data and the validation one. The step 8 is the evaluation. In this case, we are using the score, and in this case, it's really straightforward since in supervised machine learning we already have a ground truth, so we can evaluate if the model gives us the right answer. We save our model in a path so that later we can call it and zip it. As you can see here, the one that has highest performance is saved and zipped later for deployment. The model definition for the deep learning, we have a batch size of 128 and 2 epochs, and we're also creating a path to save the model. We're using a convolutional 2D network, and in order to not make this video so long, we are all these aspects and these layers are gonna be explained in the ADD document, so you can go and check it out. At the end, we do the same for compilation and evaluation, and we save the models that give us a highest performance. For evaluation, we also save it and give it a path so that and zip it, and then we can deploy it. We are using the IBM open source service to deploy our models. So we import that Watson machine learning client so that we can deploy later. Here I call the API of Watson. Then I can define a model. In this case, I'm defining 2 models: the non-deep learning one, and the deep learning one, so that we can deploy it both, and the stockholder can call them at the same time and see if they work. We deploy the Keras model. As first, we can see that it is empty. So we deploy the non-deep learning model first. So you can see it was successfully deployed, and then we deploy the deep learning one. It was also successfully deployed. And in the list of deployed models, we can see that there are 2. In case you need to erase one, you can use the code below. And this is the stockholders interface. More or less, in which you can try the models that you have. So you call it, you can see there is a 9, and the models predicts a 9 as well. So it works right. Then the interface for deep learning is quite the same, but the process underneath them are different. In this case, it also make the the good prediction. So I want to end by saying that this is the first step to build a service that can make operations with their eyes, something like that, so that if we pass a photo, he can identify first of all the numbers, then the symbols, and after that process, the order of them, and finally calculate the operations. I think that would be a great idea. Thank you.